We're starting now. I mean, the room is full. That makes it possible maybe to get you earlier to lunch. Anyway, so Rise of the Machines. 10 years ago, 2006, I was actually listening to a podcast called the Java podcast, and they were talking about a continuous integration server called Hudson at that time. And I thought, okay, let's. I mean, I knew cruise control before, and I thought, okay, let's give it a try. So I downloaded this Hudson thing, installed it on a server at our company, pointed it at that point to our CVS repository, and showed it the ARM script, and let it run. And the next day, actually, I got an email from this Hudson that said, telling, hey, you messed up this test. This test failed now. I said, I didn't do anything. I just checked in my code, and this server told me that the test failed. That's great. That's so great. I mean, 10 years ago. I think that was the beginning of the rise of the machines at that time. Said that is now continuous integration is a part of our software development that we should do. Continuous delivering, we're getting to that too. But I just want to give you a disclaimer here for that talk here. What this talk is not about. So this talk is not about how you build better pipelines. There are other good talks about that. I won't tell you a lot about the build pipeline, how you assemble that together. It will not tell you about all these configuration tools. So Chef, Puppet. I won't talk about these scripts, how to run them. And then also, I won't show you any scripts in that. I mean, probably you have some scripts running there, but this is not what this talk is about. You might think, okay, automation, what is this talk about? Well, so it's everything else that we can automate in software development that we maybe haven't thought of. So it should just give you some ideas. So I've been talking to a lot of people in our industry. What do they automate? To our employers, our people at Atlassian, what they do for the daily automation of their software development, and this is what this talk is actually about. But I want to first start with how automation influences us on our day-to-day life. We see that automation comes more and more in our day-to-day life, like this automatic vacuum cleaners that are running around our houses and our apartments, and I really love that. And I keep telling my wife that I want to have those things, but I think they cost $600 or 600 euros or something. So she said it's too expensive. I do it myself and say, oh, but it was so cool. Okay, anyway, or things like home automation. The Nest, it warms up my apartment when I'm just approaching it. Isn't that great? That's so good. And it's coming more and more. I can tell with Alexa, I can tell to turn on the lights and stuff like that. Oh, wow. I'm so excited about that. And then, of course, this year, autonomic driving cars. That's so good. Automatic cars. They are driving us around. We don't have to drive anymore. That's really, really good. I must say with cars, we're probably not there yet. We have to wait a few more years until we see them on the roads. But we're trying little baby steps. So for example, Volvo, they have this human detector. So Volvo detects actually a human when it is in front of the car, and this is a test of it. So a human stands in front of the car drives, and it stops automatically. Oh no! Oh, it doesn't. Oh. I told you we're not there yet, so maybe we shouldn't trust the robots that much. All right, so this is in our day-to-day life. So automation is a big part of that. But what about software development? Let's have a look at that actually, what it means for software development. So, as I said, my name is Sven. I'm working for a company called Atlassian. We're doing tools like Jira, Bitbucket, Confluence, HipChat, you name it. And I'm traveling around and speaking about stuff in software development. So collecting stories from software development teams and bring that to other software developers. And my story about automation goes like this a bit. When I was studying, we were doing some build scripts with Make, some GUI builders, and then JUnit and Eclipse, the refactoring thing. I thought that was pretty cool when I first tried it, that I could refactor my classes and my methods just by renaming them. As I said, Hudson was a big step for me in terms of automation, and then we tried around a little bit with Puppet and Chef to configure automatic, and then in the year, what was it, 2013, we discovered actually, or I discovered actually, Git hooks that helps us to work through the coding phase and to have some cool stuff there. So this is my story about automation, and you see that. And I was speaking with someone before this talk and said, "Oh yeah, great, automation is great. It's about automatic deployments, automatic builds and tests, and maybe some small scripts that are running around on some servers that are doing some random stuff." Yes, great. But this is just the tip of the iceberg. We can automate much more in software development. We can automate our engineering health, our support. Yes, our stand-ups. You might think, stand-ups, Sven? Are you crazy? Automating stand-ups? That's some human interaction. You will see. Then automatic merging can help us a lot. Code reviews, we can automate there something, and then the operation part of stuff. Okay. So I collected all these small things, small little, I call them bots, because it sounds more cute. If you call them bots, it sounds more human, like really someone is doing something. And I collected that and put that into categories, all these bots that I found. So you will see some coding bots, some test bots, ops bots, service bots, and report bots. So this is the agenda for today. But the first thing I actually found has nothing to do with that, so I couldn't find a category for that. Imagine you're starting new in a company, and then it's your first day, and you're gonna be you go around, speak to people, they introduce themselves, they tell you maybe what they do. And at the end of the day, or middle of the day, your head gonna explode because it's so much information. Whoever has started in a company and then traveled, go around, so there's so much information. But then you're happy, you're back to your workplace, you have your new laptop, and it looks like this. Welcome. Now let's get started. Okay, and then you probably install a whole bunch of things, and I'm coming from the Java development part of stuff, so for the next 8 hours you have to install your IDE, databases, the JDK, maybe some programming languages, and add-ons and stuff like that, and configure those so it's set up like it's supposed to be. And it's not just your setup, it's the company's setup. So what are they using in that company? You have to find out. So, of course, we also have that. People are working differently in different companies with different tools. So we actually came up with a page and saying, okay, work through that, steps here, install the following programs, install Git, Scala, blah, 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 and then you can set up your Bitbucket account and upload your SSH key to the right place. Then you can configure Maven, and then you can start Maven. And for people that has worked with Maven, you can wait actually with Maven to let Maven download the internet for you. That takes some time. And in between, you can set up your database, your IDE, and so on. And if you're still waiting for Maven, here's some articles you can read about our software development. So go there. Yeah, I mean, you probably have that in place too for new people that are coming to your office. That are new employees. So the first comment here was, or actually the second comment was, why are you not using Agent Charlie for skipping a whole bunch of these steps? Agent Charlie? What's that? Well, meet Agent Charlie. So you just go to the link, install a small script on your machine, and then let Agent Charlie do the job for you. So Agent Charlie is of course some scripts that we put together. So what Agent Charlie does, it downloads everything for you, all the tools that we use at Atlassian, installs them, and configures them automatically on your machine. So you don't have to do anything for that. And then, of course, here's some stuff. Install your stuff that you need for your productivity on top of it. and it's done. You save a whole lot of time with Agent Charlie, actually. Also, if your laptop crashes and you don't have a backup, just get a new one and start Agent Charlie, and it's installing all the stuff for you. All right, so as I said, this was just something that I really couldn't fit into this category, so let's start with some coding bots. Okay, we are software developers, and if we are going to a party and people ask us, hey, Sven, what are you doing? I'm coding. I'm a software developer. And people think that we're just sitting there and writing code the whole day. That's not the case. It would be maybe great, but that's not really the case. We're doing a whole bunch of other stuff too. So we are discussing our requirements. We discuss our cloud strategies and have to set up some cloud deployments. Then we have some issues that we have to track. We have to report on them. We're talking about our build server and have to care about that, and a whole bunch of other stuff. Branching strategies and so on and so on. So coding is actually, I don't know with you, but I think it's just 30-40% max of your time, even less. So let's get rid of some of this so we can spend more time with coding. So let's get rid of the issue tracker. Okay, we at Atlassian, we're doing issue trackers. We're doing Jira, big issue tracker. You might think, Sven, you're stupid. You want to get us not to use the issue tracker? Well, let's see. So if we look at an issue tracker workflow, it looks like this. An issue is in to-do, then it's in progress, maybe in review, and then it's done. But if you look at a coding workflow, so actually a coding workflow that we have at Atlassian, we're doing feature branches, so we branch. After that, we code, maybe do some refactoring. We're doing a pull request, and at the end, we merge the code back. Good. Okay, now we have to put that actually a little bit together. So normally it looks like this. This is what we should do. The issues in to-do, we set them in progress. We create the branch. We're doing all the coding. We're doing a pull request. We update the issue and say, now it's in review. Then we're merging, and then we update the issue and say, hey, now it's done. It's finished. Off next issue. Well, this is actually what we should do. What we normally do is more looking like this. We branch, we code, we refactor, we make a pull request, we merge. And then somebody asks us, what's with this issue? Have you worked on that? Oh, yeah, for sure. Yeah. Well, let me just update this. It's in to-do, it's in progress, it's in review, done. And that's just done in a few seconds. And everyone that looks at that is, wow, you finished that fast? Yes. All right. So said that is maybe you think, let's get rid of this issue tracker. We can look at the code and see what we've done. Well, we could, but we should keep the team updated. The team should know what are we working on, and they should have a central place to look at that and see that with a glance. And this is the issue tracker. So we were thinking about how can we improve that. So we were looking around, testing a little bit, and we found that the ABAP motive. So you can control with your mind, can control the issue tracker. So you open the issue tracker and think about this issue is now in progress. This issue is now in progress, and it drags it automatically over. Isn't that great? That's so cool. We thought, okay, let's bring that to the world. Then we were discussing a little bit and said, actually, it's more like we just don't use the mouse. We just use our brains for that. So that doesn't really help. We still have to open the issue tracker. So not a good solution. So if you look around, every issue tracker can do actually this. We call that smart commits. Well, so it is actually, you mention the issue key and then trigger the issue tracker. So you mention the key and say, this is the command for the issue tracker, and then you do it in the commit message. And actually, no matter what you use, GitHub, Jira, Bitbucket, Trello, all these tools support that. Okay, cool. That's one thing. We don't have to open the issue tracker. We just can write everything in our commit messages. That's great. So we look at that. So you write just Jira start progress. It updates, or the issue key is JRR start progress, and then it's updating it automatically. Then we say start review, and it's updating it automatically. And then we say done or fixes. That's actually the GitHub notation down there. So it actually automatically updates that. Cool, great. So no use of the issue tracker anymore. Everything in the commit messages, great. No tool switching. It's good, but it is not really automation because we are still commanding the issue tracker. It would be far cooler if the issue tracker can figure it out themselves where we are in the process. So instead of having smart commits, we're just doing this here. We're creating the branch, and the issue tracker, I mentioned the issue key in the branch, and the issue tracker sees that and automatically updates the issue. Then we do a pull request, and the issue tracker sees that and automatically updates the issue without us doing anything in the commit messages. And then we merge. So the branches merge back, and the issue tracker sees that, is automatically updating the issue. So this is actually, when I heard the people in Sydney are working on that, so our development headquarters in Sydney, I was going like this, yeah, wow, this is cool. I was waiting for that. This is so cool. So in a combination, if you use the newest Jira version with Bitbucket, that works out of the box. And I'm pretty sure that if you use something else, these vendors will just update their tools too. So I think that's a pretty much step forward for us for automating things. So this is not all. We all have small little workflow helpers that helps us with our workflow. So as I said, we're doing feature branches. So we have a branch pull merge workflow, and we have some help us, Git hooks actually, that helps us with that. So for example, if you have this cool guy and this cool guy commits directly to the master branch, that's forbidden at Atlassian. We're not allowed to commit directly to the master branch. You have to make a feature branch. But hey, this guy is so cool, he just does it, puts it in, boom, build is red. Okay, no problem, sees the bug, fixes this, build is green again. Everything's fine, isn't it? Good, we're back. No, because if you do it the proper way, maybe you create a branch in between, and then you look at it, you fix something, you make your local build, so you build just the branch, and then you find out, boom, the build is red, and then you look around and cannot find it until you discover that the build was already red before you branched it. So that was already red, so it's not your fault. That's really a bad surprise. But bad surprises shouldn't actually happen. They can be avoided. How? Well, no bad surprises. We just have a bot doing that. So we actually have a bot is maybe a big word, but we have actually a Git hook that prevents us from branching from a red build. So if the build is red on the master branch, you're not allowed to create a branch underneath. The person that has made the build red has to fix that before. So don't branch from a red build. Another little workflow helper is that we have is invite people for code review. So who should I invite for a code review? If I make a pull request, who should I invite? Well, I always invite my best friends because they are nice to me and they say, Sven, good work. We approve your pull request. Maybe not the best thing to do, but who are the best people actually? So the best people for a pull request are actually the ones that have worked with that files before, that has the original author or last changed it. So you can look at the code at the commit history and see these are the best persons actually to invite for the pull request. Now, going through all the files you changed and make and sort all this person out is a boring job. So let's have a bot doing that. So what we did is actually for our tool Bitbucket, we have a free add-on called auto-suggest reviewers. We built it, and that suggests automatically reviewers in our tool, so you can just pick them directly from there, and these are the best persons to review your code. So always invite the right reviewers. These are the right people to invite. Another thing is, so if you grow, you probably have a more strict workflow, and you want to be sure that everything goes the right way. So you want to have approvers, a minimum of 2 approvers for a pull request. And that's what we set up. So there's a Git hook that prevents merging until we have 2 approvals. So invite maybe 5 people to a pull request. And then if we have 2 approvers for that pull request, we're good to go. So minimum amount of approvers for this pull request. The next little helper that we have, the last Git hook, is a very, very special thing. If you develop for the cloud or just have one version out there, good for you. We have actually not the problem, but the challenge we're facing with having that people are running multiple versions of our tools on their servers. So we have to support them. So what if we find a bug in an older version? So this is our branching strategy for that. So we have actually branches for each version, and we keep those branches. So let's assume we find a bug in version 1.0. So what we do is we create a hotfix branch, fix that bug, and then merge back to the version branch. And now we have that bug maybe also in version 1.1 and on the master branch. So we have to merge all the way back to version 1.1 to the master branch. In that example, it's maybe clear, but if we have 10 versions, you have to merge it all the way back to the least stable branch, to the master branch. That is a lot of manual work, and if you have resolved all conflicts in the first hands, then it's very unlikely that you run into conflicts on the other merging. So what we do is actually we say if it's boring, we put in a bot and we do it automatically. So we have a script running that automatically merges these things. Actually, what it does too is it kicks off the build directly and commits that directly to our web page, so our customers can download the next fixed version from that. So we just make the first merge, and then the rest is done by bots. All right, get some help with merge jobs from some bots. So these are our coding that helps us, coding bots that helps us during our coding phase to make that more efficient. Let's talk about testing, some test bots. What we do as software developers, it's a craftsmanship. So what we do as software developers is we're trying hard to write beautiful code that actually speaks for itself, that doesn't need any documentation. So you probably had that feeling also when you've written this great class, this awesome class. Okay, there's not an awesome class, but assume you have this awesome class. Abstract class, and then interfaces, and this whole thing is just so beautiful, and you're so proud of it. You close your IDE in the morning, you open it up again, you want to see that class. You say, oh wow, it's still brilliant mind here. And then you go on vacation. You go on vacation and have a great time. 1 month later, you're coming back to your software development and say, oh, let me see that awesome class again. And then you look at it, and then, oh, people have changed that awesome class. It's not, oh shit, oh my god, they have added methods to it, and it's not so awesome anymore. Not at all. But let me tell you this. I've been working with a lot of code bases in my career, and it's always happening. That's a fact. It's always happening. If you go with your code quality, maybe everything is fine at the beginning, but then it decreases and decreases. Your code quality decreases. That's actually a fact that's happening to each code base. So why was that happening? I mean, let's assume it. We don't write bad code on purpose. We don't say, oh, that's so great class, let's mess this class up. We're not doing that. I think what we do is actually we concentrate so much on our problem-solving stuff that we said, okay, yeah, great, I put it in here, that's the best place, and then it's working. Okay, I'm leaving. Next topic. So we're just trying to solve problems, and sometimes don't see that we should actually work on the quality more. But actually, so what someone said is we need someone to look at it, and we call him Dr. Code. Dr. Code is taking care of the health of your code. Of course, Dr. Code is not really a human. Dr. Code is, of course, a bot that helps us keeping up the health of our code. And so Dr. Code is actually started when someone wanted to move our JUnit 3 test to JUnit 4. And we said, okay, refactoring, not an option to refactor everything. But we said we don't want to have new JUnit 3 tests. So stop doing JUnit 3 test. If it's a new test, do JUnit 4 test. Very simple. Just count the JUnit 3 tests, compare that to a database, value in the database, and then boom, that's it. Great. And it's so simple that people thought, okay, that's great. And Dr. Code is checking that and telling you, oh, you just wrote a JUnit 3 test. Don't do that. So actually, people wrote more and more classes about that and added stuff to it. So it's now, I think, 80 checks that we're doing with Dr. Code that Dr. Code is checking each time you checking code. But instead of letting the build fail or something, we thought, okay, let's put a little social pressure on the people. So if you got caught by Dr. Code, and that's, must say, is our culture, it's okay, you're going to put in the hall of shame. Shame on you, you messed this code up. And not only just the hall of shame, what does that mean? Well, we call you out. We put your picture on the television. Everyone can see that. And then we have a ranking. Who's the worst person here on the hall of shame? So you can really see who's messed up something. Of course, if you fix something, you're gonna be removed. And actually, if you refactor something, you also are entering the hall of fame. That's also possible. All right, talking about testing. So if we compare code, we're pretty good at reading code. We're pretty good person to read code. So if I show you that code, you probably can, just by comparing this code, tell me what's the difference here between these two code snippets. Because we can see that immediately. We are good at reading code. So you probably see that the 20, the magic number in there is new here. Great. But what about if we change the UI? What's the difference here? Well, okay, this is not really high. So you can see that the calendar symbol is different. It's a little bit hard to spot. Sorry for that on this resolution here. But I guarantee you a designer can see that immediately. They say, oh, this line is 2 pixels off. And you say, what the fuck? 2 pixels, so you can see that. This is not possible. Designer can do that. They say, something is wrong here. Okay, good. So instead of hiring new designers to look at if we messed something up in the UI of our tools, of course, we have a bot. And this bot just compares images. It makes an image by running the software, makes an image of the software and compares it with an image in the database. Pretty simple stuff. And then alerts us on differences. So if something is different, it alerts us. Well, said that is sometimes it's on purpose that we change something, new button color or something. So it's a very easy reporting. We can spot things directly and say, So you can see here, this is a report showing you the difference here. Just a red square around it and showing you the difference between those two screenshots. And then you can say, okay, this is on purpose, and you just press a button and then your build kicks off again. And puts that new picture in the database. So now said that this is great for testing. We have a lot of tests. We have so many tests because first, we are very engineering driven, so we love automatic tests. But we also have a lot of functional tests. And if Jira is now, I think, 15, 16 years old. So you can imagine that there's a lot of testing, and our test ran for hours. It's really a lot of things. So what you do if your test runs for hours, you run them in parallel. Yeah, sure, you put more servers in, and then you can run them in parallel. Great, good thing. But also here, we have to statically slice and dice our tests. So put them, okay, these 2 things are running on that server. These 3 tests are running on that server. Of course, we're getting shorter in build time, in testing time here, but we still have to wait for the longest block. We can split that up again and put another server on and let the test run on that one, but it's all manual work. So instead of that, we actually wrote a test dispatcher called Hallelujah. Hallelujah is a functional test dispatcher, and it's just taking all the functional tests and looks where there's a idle server running, and then puts it on that server. And it's amazing. I think we cut down our build time in half by just running Hallelujah. So it's really cool. So at the end, you say you compare all the tests and say everything is green. Great, we're good to go. But what happens actually? So green build status, we love that. But sometimes actually we find out that our build status is red. Ooh, test failed. Okay. It's not the end of the world. It's actually why we have these automatic tests. We want to find this bugs in the code base. So it's okay. But then you're looking at the code you changed, and you're looking at it, and it really can't really figure out why does this test fail all of a sudden. I can't really see that. So what are you doing? You rerun. Yeah, you start it again. And then the build is green. And that is the frustrating moment because you just discovered a flaky test. Flaky tests. Ooh, all flaky code underneath this. Flaky test. So we actually wrote a flaky test detector. So that detects flaky tests. And it actually goes like this. The build server finds out there's a failing build. So what we do is we rerun that test here. Just the small unit test. We rerun that, and then we find out, oh, now it's green. Okay, cool. That's a flaky test. So we put that test in quarantine, so it doesn't be executed anymore. So it's taking off the build process. This test is now quarantined, and we continue the build. So it's a flaky test. Doesn't tell us anything in here if it's good or bad. So we're testing quarantine, but at the same time, it could be flaky code. So that's a bad thing. So someone has to react immediately. So we create an issue automatically, and somebody has to look at it. And the Confluence team did it in the first half year or first 8 months. Actually, that we ran this flaky test detector, they discovered 817 quarantine tests. So 817 tests are put into quarantine automatically. People are looking at that and then saying, this is flaky code, so we have to fix that immediately. Okay, this is a flaky test. Okay, let's check that later. All right, let's look at some ops bots, operation bots in operation. So I know we're living in the age of DevOps. So we're working together with the IT person, and the age is the time is over that we just threw our code over the wall and then, hey guys, it's your problem now. Have fun with our software. These days are over. But still, I still think if something fails in production, still a slow feedback loop. So let's assume the ops guys discover a problem. They look at it, they get a notification, they try to fix it, they restart the service, whatever, can't find the bug, call the dev guys, and the dev guy says, okay, I just changed something, so I'm gonna fix it, restart it, done. That's a very slow feedback loop. Instead of that, we should remove the ops guys in between. So if a problem occurs, we have to contact the right developer that is responsible for that service, and then this developer can say, okay, I restart it again, or I changed something, so there's something buggy here, so I fix it and deploy it again. That's great, and we're using actually PagerDuty for that. So PagerDuty is a commercial tool that we use, and PagerDuty knows which team is in charge of which service, and who's in charge in that team, and then who's on duty, and then can actually send the right message to that team or to that person that is in charge of this service. Okay, this is not our automation bot in here, but there's a lot of configuration then. So even especially in the age of microservices, where you have a new service each week or each day, you have to configure PagerDuty and say, oh, now this new service, this team is responsible for that. That's a lot of configuration. So instead of that, configure it by hand, we'll be making automation configuration. So we have actually deployment descriptor, and we mentioned actually the team name in the deployment descriptor. So there's a bot, and then adding the connection directly to PagerDuty. So we don't have to do it by hand. We just put our team name in the deployment descriptor, and that way PagerDuty knows who's in charge of this service. And it goes like this: you own your code end to end. You should own your code from end to end. You should be responsible also for running your code in production. That's important here, and that way you do that. Now, a lot of people of you may be deploying each change directly. Some of you are maybe having more releases, like, okay, we have this worked for a week on the feature, and now we push it out, which is not continuous delivery, but we're still doing that. And then somebody asks us, well, wait, you have put out this new feature. What about the release notes? And especially if we deploy now from a day-to-day basis and deploy new features on a daily basis, there's a lot of release notes that we have to write, and that can take some time. So instead of writing that by hand and also putting out that you really know what's in your release that you're gonna ship automatically to the cloud or to your servers, you have to look actually directly in your commit history and say, okay, we fixed that, and that. Okay, we have to write that release notes. Or if you mention the issue key, you can go to the issue key and put that together. A lot of companies actually have done that, automated that. So they can actually see from the commit message which issue got fixed here, and then they take the issue information out of the issue tracker and create their release notes automatically. So they don't have to do that. It's actually Hazelcast is doing that. They use GitHub and GitHub issues for it. So you can everything here is just from their GitHub issues, put on it into release notes automatically, and they actually use because you don't have issue types. They use here the labels in GitHub issues for saying, okay, this enhancement, this is a bug fix, and so on and so on. Another company that's doing it is Zero Turnaround. They are actually, they have a product called JRebel. I don't know if you know that, but for JRebel, actually, they're creating their issue, their release notes automatically, but they use actually Bitbucket and Jira for it, and then they use the issue types for saying this is a new feature, it's improvement, and fix bugs. But they're doing it also automatically, have written their own scripts for that. So if you have issue descriptions actually as release notes, has a lot of advantages. First, you don't have any surprises. You don't have to look in the commit history. No one has actually accidentally not updated the issue or something like that. If you use that, you know, okay, this is really in the code. This is fixed. No surprises here. Another thing is you get human readable issue descriptions, because you think, okay, this issue description, that's going to end up actually in the release notes. So I better take care of make it more readable, so our customers knows what we fixed there. And also you think more about the customer value that you generate when you write your issue, because you know, okay, our customer, what's getting our this issue description is for our customers, so what are they getting out of when we fix that issue? So you think more about the customer value, which is a good thing. Okay, service bots. Some bots in support. Our support actually supports our servers. So they talked daily with customers, and then you look. They maybe they can't fix some issues, and then they ask for the log files from the server log files, and then look at it. And sometimes you have to contact the developers who you don't know what's wrong with this log file as a support person. So what you do is you go to the developer, show them the log files, and we developers are good in scanning log files. So we can see, okay, null pointer exception. I know that. That's normal. Oh, that's something that is not normal. So that could be, and then we combine that with our system knowledge that we have actually, and we can find the bug very fast, faster than actually the support people. Great, but the downside here is that you're gonna pause actually work. And we all know if we got paused work and work on something else because our customers want support, they want to run fast. If we're stopping our work and then we're doing support, and then we have to come back, and it takes us 20 minutes or something to go back in the flow where we have been before. That's a bad thing. Okay, the fix is, of course, no surprise. Instead of the developer, we are using a bot. And we call that bot Hercules to make it a little bit more human. We call them Hercules. And what Hercules is actually doing, Hercules can scan log files and combine it with system knowledge. How do we do that? Well, it's actually pretty easy. So we have these pages that is our knowledge base, and it tells you what's the cause, what's the problem, and then you can see here there's this machine readable part on top of it. So Hercules looks at that. It's actually a regex that Hercules applies actually to the log files, and then very easily said, okay, I found this, this, and this, and suggests that to the support person. So we just run Hercules over it. And then sometimes Hercules has a match, sometimes Hercules hasn't a match, so we make Hercules smarter by saying, okay, this was not really the problem, this is not the solution for it. So the support person updates the knowledge base always, so Hercules gets smarter and smarter. So you might think, why are you bothering your support people? I mean, you can save a lot of time if you give Hercules directly to the customers. Yes, we're trying that. So we're running with some customers some experiments, and actually the first comment was that here, well, fuck me, the robot was right, I increased the memory available to Confluence Jira and things worked. Today is a magic day. Well, fuck me, the robot was right. Great comment, great comment. And that also, the creators of Hercules thought, oh, that's so great. We're creating a t-shirt and wearing proudly this t-shirt. Well, fuck me, the robot was right. And they're running around and wearing proudly the t-shirt in the support area. Well, now, sometimes we're doing helping support, but sometimes people are coming and want stuff from us, get something fixed, want support from inside the company. But if we are currently coding and then somebody comes to us and says, hello, can I just interrupt you for a while? We say, oh, yes, of course, yeah. Well, what do you say? Put it in the issue tracker, I look at it later. Thank you. And Spotify is actually having the same issues. So Spotify actually has a self-service, and it's really a self-service machine that they have put together. So this it looks like this. It's just in front of the team room, so people can put on their name. They can enter the issue. But sometimes people you can say, go to the web page, but I lost the URL or whatever, so they can go to that room and just say, okay, save it, and then actually they can also get something away with it. So they get a ticket actually, a physical ticket. So they can come to your desk and say, have you worked on that? So that is actually pretty nice. All right, so the last bots that I have are helping us with reporting, with automating reporting. We all want that, because manual reporting sucks. So let's fix some things here. So let's automate stand-ups. Well, Sven, stand-ups, stupid guy. This is really something where we actually one time a day come together and talk directly to humans. This is our interaction. Okay, but there's something wrong with stand-ups, or some problems with stand-ups actually, that bots can fix. If you look at stand-ups, some stand-ups actually they take too long. People are talking and say, yeah, I want to go back to work. Sometimes you have to remind people that there's a stand-up, even though you're doing it every day at 10:30 or so. People forget that out in the kitchen, so you have to remind them, come, it's stand-up time. If you're working with remote workers, or if people are allowed also to work from home some days, you have to set up this VC calls, and that takes time. And also, if you're working in different time zones, that's really painful. So sometimes you cannot really get a good time to do a stand-up. If you work with a team in the States, in Europe, and in Australia, it's really impossible to get a good time for everyone to meet. And that's what we're facing. So let's fix some things here with some bots, and let's fix that stand-up takes too long. Every person just got a time here to do a stand-up. So we created this first only physical bot that I have. It's a stand-up buddy, and we built it ourselves. So it starts vibrating after a time, and you press a knot on top of it to reset it. So people are just allowed to speak until the bot vibrates, and this way we're keeping it concise, and people learn to just tell their things. So this is our little stand-up buddy that we have. So another thing that I said is a problematic that people miss stand-ups because they are in the kitchen or somewhere. So a developer from us wrote a Chrome extension, actually, and this is a very pretty simple extension. It just opens a tab at a certain time. And we let it point to URL then, and this is a music streaming service. So it starts 1 minute before the stand-up. We connect that to our television that every team has, and where we show some stuff. And then it starts playing AC/DC, and if you hear that, you're in the kitchen, hear AC/DC playing, you know, oh, it's stand-up time, so you go to your stand-up. And if you hear Taylor Swift is playing, then you know it's a marketing team stand-up, so you don't have to go. And we're using the same thing actually for setting up VC calls. So setup time for video conference calls. It's always tricky, but that way this video conference is starting automatically. Everyone that is at home or working remote can just tune in, and it's also starting and closing automatically with the Chrome extension. Okay, stand-up report bots. Good for co-located teams that are sitting in one room by playing music. Good for distributed teams to start actually the video conference call automatically to the fixed URL. But what about different time zones, if you work in different time zones? Well, that's really problematic. So we're having more virtual stand-up with that. So we actually tell the bot what we have done the day. This is our status report for the day. And then someone can go to sleep, the other one gets up, and then get all the status from all the team that it has been in the last 24 hours. So instead of having a Word document where we document all this, we're using actually chat. So you can write, it's an add-on for HipChat, and you can write /standup, give it your update, and the bot is recording what you said, and then if you just write /standup, then it's noting all the things all from all teammates with a time, 4 minutes ago, 6 minutes ago, 2 hours ago, what they have been working on, and that way we're keeping everyone in the loop. Okay, chatbots. Chatbots it's a great way to automate a whole bunch of stuff, of reporting things. If you have a chat, Slack or HipChat or any other Slack tool, chat tool can do that. So here we're posting our build failures in that, and then we can have a discussion directly in the tool where things are, so we can see this failed, and actually we can restart it directly from the chat tool. We can restart the build directly. Then we have automatic deployments. Automatic deployments, but the bot is telling us that someone deployed something automatically, or someone did it by hand, so we can see that and see, okay, our feature is now running, that's great. And then we have some integration with some exception handles, with Sentry in that case. That Sentry is recording all the exceptions, and if it finds a new exception that it hasn't seen before, it's posted it directly into our chat room and say, hey, what did you do? So people can discuss and say, okay, this has something to do with something I just recently changed. All these things are in chat rooms. So chats everywhere, chatbots everywhere. It helps actually to have faster feedback loops because it's just one source of truth, so you can see the deployment, the build failures, and stuff like that. It broadens the team knowledge. Everyone is in charge of it. Everyone sees what's currently happening. No one is surprised that the build failed, but they already know that someone is working on it, and you can start discussions directly attached to when it happens. Okay, good. So bots. How are we doing time? Yeah, good. So bots everywhere. Coding bots, test bots, ops bots, service bots, report bots, and you probably also have some bots, some cool bots that I could showcase here. It's just some random bots that I found that people are using. But what's the number one problem with all this here, automation stuff, automating our software development? I mean, sometimes it seems obvious. We're saving a lot of time. Flaky tests. Take Flaky tests. How much time did we save? How much engineering time looking at, did that, restart the build? But we never have time to do that, to think about that, to fix stuff. So time is actually the number one issue, but it's important. So tell you this story. We carry a lot of technical debt around with us, especially for Jira, old product. So the Jira team came up with that. The team lead of Jira came up with that and say, hey, 10% of the sprint time, you are allowed to work on making the code base better. Okay, so we allocated issues to it and say, okay, good, great. But instead of just working on stuff, we actually want to have that in our day-to-day basis and not just in the 10%. So actually, this developer here, Philip, he actually developed this Dr. Code, and now we're actually got reminded all the time when we change something to keep the health of the code better. So he used the 10% time for writing some automation. What we also do is we are running quarterly innovation days. So we're 24 hours hackathons each quarter. We call it Ship It days. And Ship It days are, so we really take 24 hours off and work on stuff that we really try to do. So the whole company actually takes that off. And some people are just taking the time to automate stuff, to fix something in their software development. Other people are trying out a new feature for a product or something. Other people are building whiskey bars. That's also possible. But as I said, I talked to a lot of people actually in software development, and they all said the same thing about automation. Treat your automation code well, or treat your bots well. What do I mean by that? It's pretty important that you should add them to source control. It shouldn't be a script laying around somewhere that you change all the time on the server directly. It should be in source control. So why that? Because you want to find the code, you want to see the code, and also you want to do code reviews for every change. So you spread the knowledge in the team of your automation code. So everyone is actually aware, or a lot of more people are aware of how you automate stuff and what the code changes are. Writing tests, also pretty important, especially if you're not the author of changes. You're pretty happy if there are tests that you didn't mess anything up by your changes. So writing tests also for automation code. And also, I think the most important thing is having deployment scripts. So I've been working for companies where there was a code, it was in source control, but I didn't know how to, which servers did it run or which servers I have to deploy it. So having deployment scripts in place with all the server credentials in there, and that's just so important. Talking about automation in software development, maybe we get some time off by automating stuff. We can write better code. Because software development is a craft. And like every craftsmanship, we create tools to help us to be more efficient. So our jobs won't go away. Don't be afraid of that by bots doing the coding phase. But I think we can concentrate more. It will get more and more automation actually in software development. So we can actually concentrate more on creating customer values. So this is actually the point where we as software development, where we can't automate stuff. It's really hard for bots to understand the customer and how we put that together. So concentrate more on creating customer values, coming up with better software architectures, stuff like that. We use our brains. That's the part where we can concentrate more about automating our software development. I want to close this talk with a warning that we shouldn't mess up with our bots. Treat your bots well. So if you look at bots and people treating bots not very well, that's not a nice thing. Don't do that. That's so lame. That's so lame, really. So really treat your bots, but don't do that with your bots. Because we know, if we treat them bad, we know what's happening. Right? We have all seen that. Skynet will come and take over the world. So I think that concludes my talk. So thank you very much. All right, I think I have a few minutes, 2 minutes actually for asking questions or something like that. I don't know. What's the time? How? I can just. Okay. First question: do you have timesheet bots? No, we don't have any timesheets. We don't do that. So we don't have timesheet bots, but I guess there are companies out there that have some timesheet bots that get filled out automatically, depending on if you're working on issues or something, that the timesheet is filled automatically, and you can say, okay, this person has worked 3 hours on that issue because I can see that it started, he didn't merge the code, pull request, yada yada yada. So, but we at Atlassian, we don't have any timesheet bots because we don't have timesheets. Basically that. What happens when merge bot runs into conflict? Good question. Good question. Of course, we stop the merge. I mean, we cannot do anything. We don't deploy. So it's actually an alert. So we don't merge in that case, and then just alert the developer, and the developer has to look at it and resolve the conflict by hand. That's actually it. So the bot isn't that smart. That shouldn't also can be pretty nasty then. What are your future plans for Bitbucket pipelines? It's currently not full alternative to Bamboo. That's true. So for those who knows our product, Bitbucket Pipelines is just, so it's a continuous integration delivery tool for the cloud. So it's just based on cloud services, like, so we put everything in a Docker container, let the code build in a Docker container, so you can choose your environment, and then there are some deployment things like that. So it's built on AWS and Docker heavily, which we cannot just support to server, to the server part of stuff, so that's why it won't be available for server, and that's why it's not an alternative for Bamboo. But we're currently, I don't know. I can talk to the person directly. It's very Atlassian is such stuff. But said that is we just released the first version. It's just out of beta. So expect some more stuff for Bitbucket pipelines in the future. All right. Yeah. Thank you very much again. I'm here the whole day, so come to me if you have further questions. Thank you.